All right, so this video will be kind of an overview of what's on the test for 11.1 to 11.3, and that's on, what date is that? On the 26th. All right, so first thing you want to know how to do is write out the terms of a sequence, given either an explicit or recursive formula. So let's just do something like, write out first 5 terms. Let's say a sub n equals 2n minus 6. So to find the first term, what would you plug in for n? 1. So I'll just put position and then the term. Okay, so the term in the first position, 2 times 1 would give me minus 6, negative 4. How about the second term? Negative 2. Third term? 0. Fourth? 2. And fifth? 4. So that's an example of writing out the first 5 terms given an explicit formula. Let's do the same directions, but this time I'll give you a recursive formula. A sub n equals a sub n minus 1 plus 5. Now, do you remember the extra thing that I have to tell you if it's recursive? So this says to take the term before the one you want and add 5. So I got to tell you where to start. So the first one, I'll just give you. Okay, so first term, we could just pick 3. So following this rule, taking the one before and then adding 5, what's the second term?
So you take the term before and then add 5.
Mm-hmm.
So E.
So, yep, E.
Okay.
Third term? So what did you say the third term was?
13.
13. Fourth term?
18.
And fifth term? 23. All right. So with the recursive, you got to go back and make sure you don't make a mistake, because if you mess up one term early on, it can mess up everything else after it. Okay, so let me pause for a second. I'll come back in a second, and we'll look at some more. All right, so let's see. Next one, let's look at whether or not a sequence converges or diverges. Okay, not a sum, but just a sequence. So number 2. Does the sequence converge or diverge? We'll do one of each. Let's say we had 2, 4, 8, 16, 32, and assume the pattern continues. So to figure out if a sequence is converging or diverging, you look at the terms and ask yourself, are the terms getting closer and closer to a number? Okay, so as you move down the list, are those numbers getting closer and closer to a specific value? No. What's happening to them?
They're being multiplied by 2.
So eventually, yeah, they're just approaching infinity, and that's not a number. So this is divergent. Okay. How about something like 3, 3 halves, 3 fourths, 3 eighths? What am I doing each time here?
You're multiplying by a half.
Multiplying by a half. So as you go further and further down, your number is going to get closer and closer to something. Yeah, so this converges. And what are the terms going to get closer and closer to? So what would be the next one after 3/8? 3/16. And how about the next one after that? 3/32. Let's go one more. So what kind of number is that? What's happening to it if you were to divide it out? Well, let's go one more. What would be after 3/64? Yep, 3/128. What kind of number is that? 3 divided by 128. Decimal? Yes. And it's getting close to what number? Well, let's keep going. Let's pretend finally we get to a term that's like 3 divided by 1,000,000,000. What's that? What is that? So it's getting very close to 0. So the fraction is getting close to 0. So what's happening is it's converging, which, right? And specifically, it's converging, the terms are converging to the number 0. Because if you just keep taking half of something each time, eventually it's getting so small that it's almost 0. All right, let's do one more, and then I'm going to, I'll jump back to you, Bay, in a second. Okay, any question on that one? All right, so let's find an explicit rule for an arithmetic sequence. What does it mean if a sequence is arithmetic? How do you get from one term to the next? So how do you do geometric? Yep, if you're multiplying. So arithmetic is when you're adding or subtracting. It's the same thing, adding a negative. So let's say we had the sequence 5. Let's go 8, 11, 14. Okay, so there's a formula to find what we're looking for. So there's 2 things you need to know. First thing you need to know is the first term. What's the first term here? 5. And then you need to know the common difference, which is what you add each time. So what do you add to go from one number to the next? 3. So the formula to find the nth term is a sub 1 plus n minus 1 times the common difference. And what we do is, if we can, simplify that out a little bit. So if you distribute the 3, what do you get?
3
Right? And then if you combine like terms?
2 plus 3.
Yep, 2 plus 3n or 3n plus 2, same thing. Let's check it and see if it works. So if we want to know our third term, plug in 3 for n. What's 3 times 3? Plus 2? Did it work? Yeah. And if we check the fourth term, 3 times 4 is 12. 12 plus 2 is 14. So now if you wanted to know the 50th term, all you got to do is 3 times 50 plus 2. So that's an explicit formula for a arithmetic sequence. Let's do the same thing. Let's find an explicit rule, except let's try geometric. All right, so give me any number you want to start with. 6. All right. And what do you want to multiply by each time? 3. So we have 6 times 3 is 18. 18 times 3 is 54. 4 times 3 is 1, let's see.
Thank you.
Oh, you're welcome. Are you all set?
Yeah.
Okay, very good. Have a good day. 162. Okay, so you just told me this, but what did you multiply by each time? 3. And what's your first term? 6. So the formula for finding the nth term in a geometric sequence starts out with the first term times r to the n minus 1. Okay, so let's try it and see if it works. Let's check the second term. Okay. What's if you plug 2 in for n? 2 minus 1? 1. And 3 to the first? And 3 times 6 gives me 18. And if you check it for any other term, it will work. So that's an explicit formula for a geometric sequence. All right, let's try writing something in sigma notation. So write sum in sigma notation. Let's say we had, you want to do a finite sum or an infinite sum? It doesn't really make a huge difference. So let's do 2, 5, 8, 12, and it goes on forever. So this is an infinite sum. Okay, the first thing you have to do to figure this out is to find a formula that's generating the terms 2, 5, 8, 12. And that formula has to go right there. So we just did this on the other page, same idea. So what kind of sequence is that? I should fix this one.
Okay, that's what I was confused about. It's the arithmetic.
Yep, it's arithmetic. And if you look back at the example we had here, you need to know the first term and the common difference. So what's your first term? And the common difference?
3.
And plugging those numbers in exactly the way we just plugged those numbers in right here, what would be your formula?
So
Actually, I'll put it over here to start.
2 plus I minus 1 times
2 plus, and I'm just going to do k only because when we use sigma, that's just a letter. So 2 plus k minus 1, yep, times 3. So we do that out, and what does that give me? Yep, so there's your formula. Now you just have to figure out what number do you plug in for k to get the first term. So what value would you plug in right here?
1.
Yeah. And what value would you plug in for k to get the infinite term? Infinity. If this stopped at 11, you would be plugging in 4. If there was no dot, dot, dot. But that's why I asked you which kind you wanted to do, because if it's dot, 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 you write it like that. So that's how you write a sum in sigma notation. Okay, any questions on that? All right, let me pause for a second, then I'll come back and we'll look at another one. All right, so let's try finding the sum, partial sum of an arithmetic sequence. So find the sum of the first 12 terms. Right, and I'll start you off with a few. So let's say we had I'm not going to do one that's overly tough. So 3, 5, 7, 9. So what's the pattern here? Yeah, we're just adding 2. So one thing you could do to find the sum of the first 12 terms is actually try to figure out a formula. Or this isn't bad enough. You could really just list out the first 12 terms and add them up. So what would be your terms after 9?
11.
Yep.
13.
17.
19. 21. 22.
Okay, do we have 12 yet? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and one more. Okay, and now you could just add them up. If they asked you for the sum of the first 1,000 terms, then you'd probably want to try to look at a pattern. And the way you'd look at a pattern, if they ask you to do something a little bigger, is write down the partial sum sequence. What's the sum of the first n terms in that sequence? The sum of the first 1 terms? 3. What's the sum of the first 2 terms?
8.
8. And the sum of the first 3? 15. And the first 4 terms? 4. So now the goal would be to try to find a pattern in these numbers. All right. This isn't probably the easiest one to figure out a pattern, but if you had to, it would probably be something a little easier to figure out. Yeah, I'd have to. Yeah, it's going to be a quadratic pattern. Do you know how I figured that out? So if I do one more, what did we add to get to this one? 9. And then if we add 11 to that, we get 35. So if you write all the numbers out, 15, 24, 35, and then subtract them, what's 8 minus 3? 5. What's 15 minus 8? 7. How about 24 minus 15? 9. And 35 minus 24? 11. Now if you do that one more time, what do you get in each spot? 2. Because I had to do this subtraction process twice before I got a row of constants, that means the pattern is quadratic. So it could be something like n squared plus 7. Or it could be pretty complicated to figure out. But I know it's quadratic. So if it was a problem on a test with something this complicated, I would just say what kind of pattern would it be, and you just have to say quadratic. If you only had to do the subtraction one time before you got a row of constants, it would be a step simpler than quadratic. What's a step down from a quadratic? So what's the degree of a quadratic? Squared, 2. So what's a step down from degree 2? Degree 1. And what kind of graph is a degree 1 graph? It's a polynomial that's a line, like y equals mx plus b. So a step down, if it wasn't quadratic, but it was one step simpler, then the pattern would be linear, like 3n plus 7, okay? Or something like that. All right, so we talked about converging and diverging for a series, or for a sequence. I'm also going to ask you about that for a series. Let's take one we had before. Let's take the one 3, 3/2, 3/4, 3/8. And I want to find the sum. Do you remember the formula for the sum of an infinite geometric series?
His column is like
Starts with A1.
minus R to the n minus R.
Yep. So perfect. So A1 times 1 minus R to the n. What's R in this case? Yep. 1/2 to the n all over 1 minus R. Now that's the formula for finite. So if I asked you, what would you get if you added up the first 4 terms? What would you plug in for n? Yeah. Now, if you wanted to do it to infinity, basically you can ignore this. This part disappears. Because if you take a fraction and raise it to a huge power, it gets very, very small. So if you want to do it to infinity, this is all you have. Okay, and if we do that out, what's 3 times 1? 3. And what's 1 minus 1/2? 1/2. And what do you get if you take 3 divided by 1/2? It's like multiplying by 2. Yep. 6. So if you were to add up every number in this list I have, and the rest of them all the way to infinity, you would get 6. Do you remember the term you use when it actually adds up to something, when it approaches a number? Converges, yep. So this converges to 6. So on the test, just be careful when you read the question. Do they want to know what the sum is converging to, or do they want to know what the terms are converging to? Okay, the terms themselves are approaching 0. We did that earlier. But if the sum of the terms is approaching 6.
Stop this on my desk.
Sure. Thank you.
Do you want to put it on the desk or you just want it right there? Okay, thank you so much.
You're welcome. Yeah, so finding the sum of a infinite series. And then the rest of the stuff is on what we did today. So, do you want me to go through like the binomial theorem stuff? So something like, we'll do an easy one. Okay, if I asked you to expand that, what's the first thing you're going to need to know? Yeah, and where do the constants come from? Pascal's triangle. And what row do we need? We need row 4. So row 4, quick enough we could do it out. And remember, you always start with row 0. So this is 0, 1, 2, 3, 4. Okay, so what would be the coefficient of your first term? 1. And then your variable would be, and your power. This one, we usually start at the highest power. 4. Okay, what about your coefficient for the next term? 4? Y. All right, and 3 more. Third and last one. Y the fourth. You're going to have to expand something like that. Let's see. Next thing we looked at was this kind of notation. So I'm going to value it. Eight choose 5. Do you remember what we usually call the top number, what letter that is? Yeah, the top number is usually a certain letter, and then the bottom one is a certain letter. Not A and B, N and R. N and R. N and R. So the top one is N, the bottom one is R. And we need the formula for, this is pronounced 8 choose 5. Okay. Do you remember the formula for, or do you remember something that was in the formula that we learned today? It was a new symbol. And I tried to get very excited when I said the symbol.
Oh, the factorial.
The factorial. So it's n factorial over n minus r factorial. R factorial. Thank you.
Yep, see ya.
Yep, see you tomorrow. Okay, so filling that in, what would go on top?
8 factorial over 8 minus 5, which is 30. Factorial times 5.
And when you do out 8 factorial, what does that mean?
It's like, isn't it 8 times 9 times 6? It's like 1 to 8, you would multiply all of them.
Yeah, multiply every number from 1 to 8. But you don't even need to write all that out because everything from a certain number down is going to cancel.
Everything from 5 to
Right. So 8, 7, 6, and we don't have to worry about 5, 4, 3, 2. And what's left in the bottom? What's 3 factorial?
3 times 2 times 1.
Yep, which is 6. 6 is cancel. And then 8 times 7? 56. So if I ask you to evaluate 8, choose 5, that's all you have to do. Any question on that one? And then the last type of problem on the test is something like, let's take x plus y to the 12th, and I want you to find the x to the 5th, y to the 7th term. All right, so when you expand that out, how many terms do you get when you expand something to the 12th power? You get 13. So if you want to visualize it, there's your 13 terms. And the first one would be x to what power? X to the 12th, and then this would be to the 11, 10. So that's the term you're looking for. So if you were counting, it's actually the eighth term. All right, so whenever we count though, we want to be careful. What do we usually start with because of Pascal's triangle? We always start with 0. So if you're actually counting it, it is the 8th term, but the way we count it with Pascal's triangle, we're going to be looking at column 7 in Pascal's triangle. So what row are we using of the triangle? Yep, row 12. And I just said column 7. So if you can figure out what that is, and then just tack that on the end of it, that would be the answer. You just have to do this out. Any question on how to do that out?
So you do that on using like the triangle.
Yeah, exactly, just like we did right there. Yep. Do you want me to do that one out, or do you think you could
Sure. You can just do it out.
just do it out?
It's not happening.
All right, so what would go in the top?
12 factorial.
Yep. Factorial. And in the top, everything from what down is going to cancel. And what's still left in the bottom? 5 factorial. Okay, so we have to cancel, and everything is going to cancel out. So what should we reduce the 5 into? Okay, how many times? How about the 4? 4 goes into 12. 3, we could just cross the 3 out. And then 2, we could just cross the 2 out. So what am I left with for a calculation? 11 times 9 times 8. So 792. So the term that I'm looking for would be 792, x to the 5th, y to the 7th. And that's it. So that's kind of a quick overview of everything that's on the test. Okay, any other kind of general questions? No?